How to graph systems of inequalities. Have you ever wondered how to visualize relationships that are not just equal but also less than or greater than? Graphing systems of inequalities can help you see these relationships clearly. Let's break it down step by step to make it easy for you. First, start by understanding each inequality in your system. Each one can be represented by a boundary line. To find this line, convert the inequality into an equation by replacing the inequality symbol with an equals sign. For instance, if you have the inequality y is less than to x plus 3, the boundary line will be y equals to x plus 3. Next, it's time to graph that boundary line. If your inequality includes greater than or equal to or less than or equal to, draw a solid line. This shows that points on the line are part of the solution. If your inequality uses greater than or less than, draw a dashed line. This indicates that points on the line are not included in the solution. Now let's determine which side of the line to shade. The solution to the inequality will be all the points on one side of the boundary line. To find out which side to shade, pick a test point that is not on the line. A common choice is the point at coordinates 0, 0, unless it lies on the line. Substitute this test point into the inequality. If the inequality holds true, shade the side that includes the test point. If it does not hold true, shade the opposite side. Repeat this process for each inequality in your system. Graph the boundary line and shade the appropriate side for every inequality on the same coordinate plane. After you have shaded all the inequalities, look for the area where the shaded regions overlap. This overlapping area represents all the points that satisfy every inequality in the system at the same time. Finally, to ensure your graph is correct, pick a point from the overlapping shaded region. Substitute that point into each inequality. If all inequalities are satisfied, you have successfully graphed the system of inequalities. Remember these key points. Solid lines include points on the line, while dashed lines do not. Shading above the line means you are dealing with greater than or equal to, while shading below indicates less than or equal to. Graphing systems of inequalities is not just a math exercise. It has real-world applications. For example, it can help in budgeting where you need to meet multiple constraints at once, or in optimization problems where you define feasible regions using inequalities. By following these steps, you can confidently graph systems of inequalities, making the process straightforward and accessible.